Welcome to the quick demo of Smart Traffic Lights or STL Web. STL Web is a one-stop application that provides simulations on automated density-based traffic light signals with an additional dashboard to monitor the traffic flow. We provide three core features, namely vehicle detection, traffic simulation, and the last feature that is hidden behind my image, analytics dashboard. For the first feature is the vehicle detection feature, or the foundation of why STL can work in the first place. Here we use a machine learning model that has been fine-tuned to perform better than Amazon Rekognition in the use case of detecting vehicles. As a disclaimer, for higher quality pictures or those with more than 1 megabytes in size, we have a priority configuration where users can choose either to prioritize speed or vehicle quantity. To demonstrate the difference, let us try to set the priority configuration as speed and try to upload a 1.6 megabyte size file. As we can see, only after a short while, the detected image has been returned in the left side, and the vehicle count details of total 15 has already been returned on the right side. Meanwhile, if we switch it into vehicle quantity and upload the very same image, if you notice, it will take longer than usual, but not so much, perhaps only an 8 to 10 seconds. But the vehicle count returns almost twice as much as the one that prioritizes speed. But not to worry. In this case, for low quality pictures or the files under 1 megabyte, these two attributes can go hand in hand without compromising one to the other. To demonstrate, if I select vehicle quantity as the configuration and try to upload a low quality picture that is taken at night, it immediately returns the detected image with a total vehicle count of 10 cars. This feature is better than Amazon Rekognition as to compare. As you can see in the recognition console, the same image does not return any detected vehicles and only give a misdetection of a bridge. This vehicle detection feature will then be integrated into the traffic simulations feature. Users are given a UI display of an intersection where they can add a traffic lane by specifying the lane name and the video streaming URL. As a disclaimer, user can also add 4 roads, but we're going to use 3 for now for the sake of simplicity, and because in the real world, I'm referencing a intersection from Medan that has only 3 roads, which is the M Yamin intersection. Before we start, users can also edit the traffic light configuration as they prefer. For the simulation, if they would like to stop at a certain number of turns, they could specify it, but let us now leave it as default or infinite. Users can also change the green time range with a default of 10 seconds minimum and 60 seconds maximum. They can also change the vehicle to green time ratio. Okay, what does this mean? To put context, ratio can vary among intersections. For example, intersections with wide roads can have 10 vehicles that pass the green light in under 5 seconds. But for intersections with narrow roads, the same number of vehicles of 10 would perhaps require 10 seconds to pass the green light. So here, the user can customize it based on the current intersection of how it is. And lastly, they can either enable or disable the traffic flow logs that can be used for data analytics. Let's save the changes and let's start our traffic simulation. When we start, the video stream will be captured in a snapshot, and it will start to analyze the images. As you can see, this has the most vehicles, so it gets a green light. But how is it happening behind the scenes? The score is the product of the vehicle count times the probability of it getting a green light. The probability will come from the history. Let's see in the next decision. Now myamin2 gets the green light. Meanwhile, myamin1 is stored here as the green light in the history. And the probability is the lowest among the rest. It only has 0.25 and the rest gets 1. When it switched to the green light to myamin3, myamin2 now is added to history and it gets the lowest probability. The second lowest is myamin1, and later this will be the lowest after it changed. As you can see here, because it has recently gotten a green light, that's why it has the lowest probability. Meanwhile, for the green time itself, it is calculated based on the vehicle count of the green lane times the ratio that we provide here. If we try to change, okay, maybe 10 cars would only need 5 seconds to pass. Later in the next decision, the calculated green time will change into 5/10. Let's wait until the next decision arrives. When we are analyzing, as you can see, myamin1 with 29 vehicles now gets half the time because we have changed the ratio into half. And now the actual green time follows the calculated green time. Lastly, we have the analytics dashboard feature. This is an embedded dashboard from QuickSight where users can configure as much as they like on which analysis to conduct to monitor the traffic flow. For now, we only add total intersections that are registered in the system, average vehicles per day and its details, the vehicle count for each road, which road has the most vehicles, the trends of vehicles, and of course, we can also separate it per intersection, intersection A, B, C, D, and our intersection is now D, which is the myamin intersection. This can be used to give insights, to do city and operational planning, to do some maintenance, and many more cases. If you wish to know more about STL Web, you can read it in the landing page here. And if you like to set up by yourself, you can see the architecture diagram on the left and the infrastructure as code reference provided on the right. Lastly, you can refer to the GitHub repositories of each web, API, or even the Jupyter Notebook in conducting the ML model research. That is all. Thank you.